Welcome. Hope you are good, and we are back at the third part of this Let's Build. Last time we ended at the track chain assembly here because I couldn't quite figure out how to get it attached here to the hot end carrot, and also the frame wasn't perfectly square, and not all the parts here were at a perfectly straight 90 degrees. So we'll start with getting that straight, how to assemble it properly, and how the orientation works, and how to get the track chain mounted properly. Let's start with the track chain first. To assemble the track chain, you will need to remove the screws on both sides, here and here. Then you need to take the washers, which are below the nuts, and put them on the screw, then the screw inside the track chain, and then the nut on the outside. Especially here, you need to make sure that the track chain points a little bit upwards before you screw it down. Otherwise, the track chain will get tangled up here with one of the pulleys. If this is too low, it will interfere with the belts and with the pulleys. So you need to make sure that this is slightly tilted upwards. The same way applies for this one, the same. It should be slightly pointing upwards, though it's quite difficult to get it pointed upwards here, because the screws for some reason are not hex screws, but Phillips head screws. Not quite sure why they did it, but that's how they do it. That way you can get the track chain to work without interfering with anything. Again, not the best way, but that's the way to do it with the stock parts. The second thing was that the frame wasn't perfectly 90 degrees in all corners. To get that working and to get that fixed, I had to loosen some of the screws and then pull it in certain directions. For example, mine was here completely at the edge, and here was a little bit of space left, like this. Here completely on the side, and here a little bit space left. To fix that problem, you need to undo the screws here and here on the opposite corners, and then grab it here and pull it towards you and tighten it, and then screw down the bolts again, the screws again. The best way to do is to unscrew them a little bit, pull them, and leave the carriage here to see that they align properly. Pull it, and then it should align pretty darn good. Make sure that you pull a little bit more before you screw down the screws, because it will relax a bit afterwards. And if you have the opposite problems, or if there's a little bit space here and here it is completely at the screws, then you need to do the same thing, just the opposite way. Undo the screws here and here, move the carriage to the end, pull a little bit, screw everything down again, and that should fix the problem with it being a little bit problematic here. I had the problem that these corners were not perfectly straight, and that's the best way to fix it, in my opinion. The next thing was to ensure that these things here are perfectly 90 degrees on both sides before you do this straightening out of the frame. Basically, before you straighten the frame, do this. And the last thing, which I have to correct myself on, because frankly I overread it in the manual, it's not particularly great to see, and you can easily forget to read that part. These screw mounts here, the threaded insert, the threads here, need to point in directly this way. So this means here and here are M4. Those need to be on the same side. And this one with the 2 screws here additionally needs to be on the right side. And the orientation of the 3D printer, this is the front. So the R needs to be read from this way. L, R. And if you read it from this way, from the front, then these 2 additional screws need to be on the front the same way these M4 need to be on the front. Otherwise, you will get problems with the assembly of the end stop there, which is going to sit there. And I think this covers everything which did not quite work out in the last part 2 of this Let's Build. So I guess let's continue instead of going on. Last part was sliding plate assembly, as they call it, which is pretty much the X and Y carriage here, alongside the hot end and the switch here. And the next part is the XY axis motors. Why they aren't calling it slate? Well, I don't know why they aren't calling it sliding plate motors. They should be a little bit more consistent with the naming scheme here, but in the end this is the proper naming. So XY axis motors and wheels assembly. So for this we are going to need again our frame. This is pretty much what we're going to need anyway. Then the 2 X and Y stepper motors, as well as the pulleys, which should be somewhere around here. Yes, these ones. So not a lot of parts, but quite important parts. So let's see the way they want us to orientate this thingy. I need to switch sides here. This is the L side, so this goes here. This is the R side. Right side goes here. And the right side wants the X stepper motor. And the left side wants the Y stepper motor. Okay. So. And on the front are the pulleys, and on the back are the stepper motors. Okay. So let's get our assortment here. Okay, that looks right. This is right, and it goes on like this. So somewhere like this. Supposed to line that way. Okay. So this looks right. Same for this side. These T-slot nuts, or as they call it, the bolt nuts, you need to make them a little bit, unscrew them a little bit, otherwise they won't fit in there. But if you are at this point of the printer build, I guess you already noticed that this is the way to do it. Okay. They don't mention that you also need M4 screws. Great that they mention it at all. So let me search for those. They should be M4 by 16, which is this package. Here, trusty knife. Those should be M4 by 16. Okay. M4 by 16 millimeters. Okay. Okay. These two screws are in package B, so B package for the XY axis. Again, why they aren't telling you that is in package B, I don't know, and why they are missing the screws to tell you what you need in the bit on the top of the manual part. I have no clue, but well, that's something. Okay. These are in place now. And they specifically tell you not to tighten them down, screw them down all the way. They specifically tell you let them stay loose. This is important later for the belt assembly, so I repeat it here again. So this was an easy step. The important thing is, again, these motors here also need to be loose, so the screws don't set them too strongly, don't screw them too strongly, because you will need to later shift them here a little bit, move them here around a little bit, and later on you're going to use these longer screw holes, these elongated here screw holes, to tighten down the belt completely. You will need to do a little bit here on the hot end, but the final step is going to be done here with these screws. So now the most complicated part, probably, which is the belt assembly. CoreXY kinematics are a little bit more complicated than your usual kinematics, like the Cartesian one, which often is used for the i3 style printers. Only the deltas are, in my opinion, even more complicated in terms of calculations, though in terms of assembly, the CoreXY probably trumps them all, especially if you buy a complete kit. So these should be the belts. Okay, a lot of this organizing stuff. And these cable ties, we'll need them as well. There should be two of them, yes. One for X, one for Y, even though X and Y doesn't really exist here on this printer, in the traditional sense at least. And they gave you the right belts. There are three different types of these belts. There are the ones which are only made out of rubber. There are the ones with fiberglass reinforcement, and the steel ones. It's important to remember that the rubber ones are completely rubbish for this, because they will pretty much stretch over time and come completely loose. You would think that the steel ones are the best of all of them, but they have one huge disadvantage, which is they will break over time. The steel is not as flexible as the fiberglass. It's a lot more stiffer than fiberglass as well, and it will result in some stresses on these metal threads in here, which will eventually result in them breaking. And that's not good, because that will lead to the whole belt failing at some point, or at least stretching. So the best thing, even though it's not the most expensive, is the fiberglass reinforced belts for the CoreXY. For something like a Cartesian one, where the loops around these whole things here is not as complicated, you can get away with the steel reinforced ones. They should last quite a long time. But with a setup this long and with this many loops here around corners and stuff, it will eventually break. Not like in a day or something, but it's not the best way to do it. So let me get this diagram straight here. Synchronous wheel, yes, this is clear. Okay, this is supposed to loop around here. So this one goes this way, around here, and here. Okay. And there's no easy way to do this. You need to use the zip ties, which are supplied, and you need to align the teeth here to basically grab into one another. That way you will get a relatively tight fit. It would be better with something different, but again, this is a pretty darn low cost 3D printer, at least for the size. So I guess they had to make some decisions here on quality, unfortunately. So you should use 2 zip ties. A little bit overkill, but this will prevent the belt from slipping on itself. Especially with it getting accelerated and decelerated really fast. This should help keep the problem down. Okay, that is sufficient. So this is one part. This one goes in the lower part. If I'm correct, yes. Lower part. Let's leave it there. That was the X carriage. This was this part. And this is the other one. Okay. So this one is the X, which goes the other way. Yes, okay. Perfect. Goes here. Goes here. And attaches to the right side here. Yes. And again, two zip ties. Okay. So this is the basic, this is the first part of the belt assembly basically. You have the two belts here on either side, on the left and the right side. On the right side, so this one with the air, the belt goes on the upper part here. And on the left side, the belt goes on the lower part, so on the lower pulley here. And they first start out by going here, by going to the motors. And then they make basically a turn here. Oh, okay, they aren't screwed down yet, sorry. This is a little bit too much for us. So let's assemble this one first. Make it a little bit easier on us. So this goes here, goes around here, here, and here. And then hooks onto here. This looks good. This one goes around here, here, the upper part, and goes here, clips in here. This looks about right, perfect. Okay, looks good. Good enough for me. Now let's get these things straight. So now the difficult part here is to align them perfectly in a straight line, pretty much. This one should be here, okay. This looks good. Too small. This one a little bit loose. This one needs to be loose as well. Okay. Oh. Okay. Okay. Down. Here. And this is basically how the loop goes. Yes, looks good. Okay, now comes the really difficult part. We need to get into the printer here. First we need to get these ones here on the right level. And this one needs to be relatively high. Right here. Okay. Okay, this one is it. A little bit of tension is required here. Okay, this is good. Okay, this one. Like so, that looks good. Yes, parallel, perfect. As a good way to align them easily, you can flip this one. So the thicker part here from this one goes down and the thicker part here goes up. And that makes the alignment here so that they are on one level a lot easier. The next part is not a complicated one. We need to get in the printer here and get both sides to be a little bit tighter at the same time, which is going to be a little bit challenging. Let's make sure that there's nothing that overlaps. Okay, this is okay. Sorry if you cannot see this part perfectly on this camera, but on the top-down camera you will see it way better, hopefully. But this is a rather difficult part, because if you get one side if one side is too short and the other one is a little bit longer, they will misalign these parts here, so they won't be a 90 degree here on 90 degrees, which is not what we want. We want them to be 90 degrees. So basically we will need to move this one in the middle and back. Back. Yes. Now we need to get some tension on these belts. Okay, looks about right. Okay. Let's get these zip ties in first. And the other zip tie here. Okay. Zip tie here, come on. Okay, this one is on. Okay. This looks good. Very good. This one a bit down. Okay. So now the whole belt assembly is a little bit under tension, and we can now move the motors here to get them parallel to one another. So to get them parallel from here to here, which you can see on these belts here. So they should be on top of one another. Loose these screws a bit. Okay. Okay. These need to go down a bit. Okay, this is right. This one needs to go up a bit. Okay. So this concludes this part. All the belts are aligned properly. And all the belts are connected. There's no problem. Don't make a problem out of it, at least. It shouldn't make a problem that these belts are not perfectly nicely flat and straight. Over time they will get better. They will flatten out a bit. That shouldn't be much of a problem. Then put here to the side. Okay, now. Okay, this looks good. So the last part of this is to extend these motors a little bit outward. This is done by loosening the bolts here and pulling them just a bit. This gives the extra tension these belts need. Okay. This one was quite loose. Oh, there's one nut failing. Okay, now they are right. Okay, that looks good. Oh no, this one wasn't. This one did not look good. Okay. Okay. Okay, this is good. Looking good. They are nice and tight. The problem with a printer this size, you won't get them perfect. The size of this printer is just so enormous that no matter how much force you basically put in them, they will still give a little bit slack. So this is perfectly fine if they behave like that. They should give a little bit of force on your finger if you try to bend them in a certain direction, but it shouldn't be like so much that you basically have to use all your force to get these motors away from the frame, and just make sure that they are nice and tight, and get these motors to get a little bit more tension on them, and then you should be fine. And the last two zip ties. This one is a little bit too high. Yes, okay. A little bit lower. Maybe a little bit too aggressive here. Get them all right. Okay. Bend inwards a bit. That's a bummer. The toothed ones might have been better here to keep them in check. We'll see whether we can do something about it later. But as you have heard just now, the belts here grind on the outside of these of these gantries here, of these pulleys, which obviously is not what we want. This is quite annoying, but we will need to figure out a way to solve the problem later. Let's get the last zip tie in here. Like this. Okay, looking good. Okay. Now we can trim the excess of the belts off. Don't just cut them here on the last bit. Leave a little bit of extra here, just in case. Okay. Looking good. Let's see. Okay, they don't interfere here. And here as well. Perfect. And now I can finally demonstrate the CoreXY principle. Because, as you can see, we have these both stepper motors. If we pull on one side, it will move diagonally, as you can see. And the other side, the exact opposite direction. And only if we pull on both sides can we actually control which way the gantry is supposed to go. So if we pull both sides down, so away from the front, this is again the front, this is the back, to the back, moving to the front, pushing or pulling to the front, it moves to the back. If we push and pull in opposite directions, we can make it move like this in the left and right, basically. And that's the whole idea behind CoreXY. Pretty much the whole idea. So let's look into the manual, what it's telling us. Synchronous wheel, yes, we did all that. All of that. They are telling me that during the printing process, the leather? I don't think this is leather, this is more like rubber, has a slight sound, which is normal. Well, I'm not sure whether this grinding noise is the slight sound or whether this hissing sound from the stepper motors is the sound they mention here, but okay. Same plane up. Okay. This concludes step 5, belt assembly. Next step is the bearing assembly, linear bearing assembly for the hot blade or the blade. The next one, step 7, is then the Z-axis assembly, and after that only electronics. So the next 2 steps will be in part 4 then, and we'll see whether we can finish with this one or whether we will need our part 5. I think we will need a part 5 because we will need to discuss some things like getting the dual Z-axis aligned properly, which takes some time, and we will also need to clean out these linear bearings because they are often not the highest quality, and the lubricant may also not be the highest quality. So we will discuss how to clean them and how to install all of these parts. So part 4 will be pretty much the bed assembly and perhaps the controller board assembly, depending on how fast we get through this. So I hope to see you in the next part of this Let's Build series of the Tronxy X5SA 500 Pro, and hope you are enjoying the series, and well, let's meet next time. Thanks for watching.